Are you ready? Okay, thank you. Okay, hello everyone. First of all, thanks for being here and staying with us. Okay, it's great seeing you guys here. We are from Extend Studio, and we are here to talk about one of our most favorite features of Unity, Coroutine. Yeah. You might not believe it, but we use it almost everywhere in our game. My name is Nainin. You can call me Pop, okay? And gentleman over there is my colleague. You can call him Big and Arm, okay? So Pop, Big, Arm, sounds good, okay? Big is the one who look more handsome, okay? That you can notice him, okay? Extend Studio is an independent development house we found in 2008. And our goal is to create the amazing title that we can share with everyone in the world. So far, we are lucky enough to claim some awards such as the Dream Build Play, the Indicate Festival, and also we got mentioned in the IGF China last year. Our title includes Ares Extinction Agenda on PC and Xbox, and Jigsaw Mansion on iOS. And our latest game is called So Many Me. And since today we will take So Many Me as the example for the presentation, so let me tell you more about the game. So Many Me is a puzzle platformer 2D games in which you play as Philo, who is a green blob who has an ability to control his many clones called the Me. Okay, these clones possess all sorts of fun ability. They can transform into many useful things in which is a key that you use it to solve the puzzle throughout the game. And as you see in the picture, the game is presented with the cute and beautiful family-friendly art style. And this is our main character, Philo. Okay, you will see him a lot today in our presentation, so you might want to say hi to him. Hello, okay, thank you. And this is the trailer. Please enjoy. Whoa! Okay, and that is the video. Do you like it? Thank you. Okay, in So Many Me, there is one design guideline that we would like to share with you. Every action of Philo that you have seen in the video and any interaction between Philo and the object in games, we would like to make them all feel smooth and responsive. Meaning, nothing will move instantly without animation and transition. Okay, this way we feel like the gameplay experience will be better. And in the next several slides, my friends and my colleague, Big, will talk and discuss about how to implement some of these actions with coroutine and update function. Please welcome him.
Thank you, everyone. Hi. Let me introduce again. My name is Chanyut. I am a programmer in the SoMany project. Today, I will show you how to implement the responsive and smoothly animation that we use in SoMany. Okay. Excuse me. I want to know who in this room is programmer. Please show me your hand. Wow, a lot. Okay. Anyone has ever used Coroutine? Okay, I can say that you are in the right session. Okay, my session, I will start from the easiest thing, which is, I will tell you that how to implement the feature in update loop. And then I will show you the same scenario, but implement it in Coroutine. So you can compare between them. And you can see the benefits of a coroutine. And then my friend Chakkapun will show you more complex scenario that coroutine can help you implement it. So let me start a simple thing. Okay. Scenario number 1. Let's see the video. Okay. Philo pick up a key card. Sorry. As you can see, when Philo touches the keycard on the ground, the keycard will move slowly into the Philo head. Just notice that a keycard did not move to Philo head instantly. It slowly and smoothly moved to your head. This kind of feedback enhance the player gameplay experience. So let's see the code that implement this. Okay. At first, I will show you how to implement it in the update loop. It's quite simple, and everyone here is programmer. You can understand it in just 1 millisecond, right? Okay, it's quite simple. In update, decrease peak timer with a delta time, and then update the position of keycard with a linear interpolation between two endpoints. Okay, it's still easy and simple. Next, scenario number 2. Philo enter a portal. Okay. In this scenario, this is combined of many sequences of action, just like Philo will walk to portal and then fly into the center of portal and then delay for 0.8 seconds and then the scene was fading out and next scene was load. How can we do it in update loop? So let's see the code. Okay. You can see that code, it looks more complex. In update, it's divided into the 3 states. It's like a state machine, right? The first state is sucking state. It takes responsibility to move the Philo from the ground to the center of the portal. And then switch to next state. The delay state, it's just simple. It's just delay for 0.8 seconds and then move to the next state, fading state. The fading state it has a lot more code, so I cannot put it in here. So I write it as ... but it's a million lines of code. I'm just kidding. Okay. You can see that? Oh, sorry. Yes, it's more complex than the previous one, but it's still readable. Okay, you may take about 10 or 20 seconds to read and understand it. Okay, let's see the last scenario that I bring to you. Is Philo and the gang get into the portal. Okay, now we have more than one flow. So how can we implement it with the update loop? Can you imagine that? What update function could be? Even if you can reuse the code from the scenario number 2 and put it more like including more variable to hold up each state variable is still more complex and take more time to read and understand. So we come up with a better solution, which is Coroutine. Coroutine will make our code more readable and more understandable. Okay. Now I will give you the definition of coroutine. The coroutine system is powered by C# enumerator, which is a simple but powerful interface, which allows you to write. It's quite difficult to understand, so just ignore it. Right now, I will give you an example that helps you to know what coroutine can do, and you will understand it like me. Okay, let's go. Okay, start with the scenario number 4, fetching an object. Again, it is very easy function, right? But when we run this function in update, what happened? It disappears instantly. Yes, because it's a normal function. The normal function will run at the beginning until the end in just one single frame. That's the reason why object was disappear instantly. The for loop was run in 10 times just in one single frame. Okay, I rewrite it into the coroutine. Okay, what I changed? The first one is I change void into the, I change void to enumerator, and then include the line that called yield return now, and that's magic begin. Okay. Yield return now. That this line is a point that Unity pause this coroutine execution, and then leave coroutine and execute more code, anything else, and then get back to this coroutine and continue the next iteration of for loop. So an object that attach this component, they can fading off and then disappear. That's coroutine. So, okay. Let's see the scenario number 5. Philo pick up keycard with coroutine. As I showed you before, I implemented with the update loop. Can you remember update function? It's quite simple and easy, yes? And pick coroutine is quite similar to the update loop. What the difference is just I add yield return now into the while loop. That is coroutine. Okay. Then, and previous example, I showed you how to use yield return now. Unity provide more useful function based on coroutine, which is wait for second. Wait for second take one parameter, which is the duration you want to wait. I usually use it when I want to delay something. When I call yield return now wait for second 10, that means I want to delay 10 seconds before do something else. And wait for end of frame and wait for fixed update. As it's two useful functions. You can see the description and example in the API reference. Okay, we are going to scenario number 6, Philo enter a portal with coroutine. In update, when I implement it in update, I have to implement it like a state machine style. I have 3 if clause with a variable that hold up the value of each state. So how about coroutine? This function, this coroutine is named enter. It simply divided into 3 parts. The first part is the first while loop. You can see that. Oh, mouse is not show up. Okay, you can see the first while loop block. The first while loop block take responsibility to move the Philo to the center of portal. And then when this while loop ends, the next part is give return wait for second. It is delay about 0.8 seconds, and then to the last part, which is second while loop. The second while loop take responsibility to fading out whole scene and then load next scene. This is the way we deal with coroutine. As you can see that enter coroutine is quite good looking, but I can do it better, more readable and more understandable. So the code will look like this. Okay, I create 2 more coroutine, which name is step move in, the red character. Okay, and then I move the first while loop into it. And next coroutine that I create is step fade. Then I move the second while loop into step fade. And finally, my enter coroutine will look like this one. We have just 3 lines left in enter coroutine, so it's more readable and understandable. Okay. Scenario number 7. Philo and his gang enter a portal with coroutine. Philo is not alone. He can clone himself into 1me, 4me, or more. So how can we do it with coroutine? I just change a bit in the enter coroutine. The first place I change is its parameter. I change transform to array of transform. So the enter coroutine can receive more than 1 Philo. And then I use for loop to get each Philo from that array, and then start coroutine step move in for each of them. So the result is in this video. Okay, you can see that the Philo, when the first Philo move into the portal, when it disappears, the second Philo will jump into the portal, follow the first one. But you notice that the second Philo will wait until the first Philo disappears. Why? Because of this line. This line, yield return start coroutine. If we have yield return, that means you have to wait until that coroutine is finished, and then get back and continue the execution. So if we remove yield return and leave coroutine alone, and leave start coroutine alone, like this, so what happened? Philo didn't waiting for each other again. It will look like this.
Well, man, I'll try that. I don't know, my kill speed.
Each Philo have a delay about 0.3 seconds, like we coding in the coroutine. You return new wait for second. This line. Okay. This 7 scenario is quite simple and still easy for you. But then Chakkapun, my friend, will come here and tell you more complex scenario. Okay.
Okay, hi. Thank you, Shanjut. Now that you know what coroutine is and what it can do, let me show you how we use such knowledge as a major part in designing the code structure. So, we have seen that an enumerator function can be invoked by passing it into start coroutine method, right? Now that start coroutine method the start coroutine method is actually a function that has coroutine as its return type, and it can be used directly in use statement. As you can see here, if we create a public function that calls start coroutine for us, right? Other coroutine in other object can use this function directly. Let's take a look at some code from Philo class, which is our main character. We make this Philo movement function as a public coroutine so we can call them from anywhere we want. And better than that, we also have an option to wait until this movement finishes before doing anything else by using it. For an example, this is a red jelly class. It is a big jelly that has a collider attached to it. When Philo is in range of that collider, this trigger will function. The mouse is not showing. Okay, I got it. Okay, so this trigger will trigger once Philo gets in range, and it will start this coroutine for us. This coroutine is a combination of 3 different actions from Philo's action. There are panic, jump, and walk to. As we call jump, right after panic, without yielding. You see, there's no yielding here. So these 2 actions will start simultaneously. And walk to, on the other hand, will start right after jump is finished. Let's see the video. So here's the result. Okay. The exclamation mark, that is the panic, right? It starts along with the jumping. Okay. We already saw how a class can be designed around coroutine idea. Now let's take a look at how we have utilized in a bigger scale. In fact, in almost every game, object in so many me, we use this coroutine structure. We barely have any code in the original coroutine. Sorry, we barely have any code in the original MonoBehaviour update. I will show you 2 areas that has great benefit of this design. The first one is in-game cutscene. So this is a cut from the game. When Philo meets his heroine for the first time. The sound is so loud. So other than Philo, we also have other me that has its own personality, like study me or brainy me or something like that. And this is how we do it. As you can see here, each action in the cutscene is actually just one line of code that's being put after another. We can choose to run more than one action at a time and can make it happen after another, or we can wait by delay it before it starts. For example, in this code, I try to find a mouse here. Okay, never mind. Let's say in the middle of the screen, there is a me character that will start walking 0.5 seconds after the camera starts panning. He will then turn his head to the right and start talking. And then brainy me will start walking again. Okay? The best thing is the code looks nice and very easy to understand. Even if you are not a programmer, you can understand it. The second area I will show you is the AI. As I mentioned, that almost all object in the game is based on coroutine. And that includes enemy and bosses. As we can wrap up the entire move sequence of a boss into a single coroutine. And we also know when it will end. Because of that, implementing AI becomes a lot easier. So this is a part of AI from Chakkapun battle scene, which is one of the boss fights in the game. You will notice that all actions are pushed into this small coroutine in the red box, right? And it's all controlled. It's all being controlled by this big coroutine one. And this is a video showing AI in action. Okay, each action is one coroutine, yeah, that being executed after another. So in conclusion, we think that coroutine make our code structure look nicer. It's a great tool for developer to be able to work more efficiently, because it can make both programmer and designer to have the similar point of view of the game. Sometimes the designer himself can comfortably adjust things directly from code. And again, the best thing is it's easy to maintain too. But nevertheless, I'm not saying this structure is always the best. There are many cases that it can make things more complex for no reason. But we would say that it fits very well with games like So Many Me. Okay, so that's it. If you have any feedback, feel free to send them to either one of these emails, and you can win a free copy of So Many Me. Okay, and if you have questions, feel free to ask. Okay. That's one first. Thank you.
Thank you. Hello. So in Coroutine, it runs in sequence, right? But if you want to stop it in like in the middle of running. Like
Start it in the middle of after coroutine.
I mean, example like boss is running and
Yes.
then takes damage from the player, and then